Okay, here we are in our last lesson of quadratics. So these are our quadratic formula word problems we're going to look at. As I mentioned before, this question looks familiar because we did it at the end of the last lesson. So we're actually going to skip past it right now. All right. If you're confused about it and want to go over it again later, just stick around at the end of the lesson and we can talk about that. So we are actually going to start with this NASA question right here. Now, if you don't have the quadratic formula handy or memorized, I'd write it down somewhere nearby. Here right now, as a challenge, see what you can remember for the quadratic formula. Write out what you know. Did you write x equals negative b plus or minus the square, I lost the square root symbol, plus or minus b squared minus 4ac divided by 2a? If so, great work, guys. Another reminder is this section under the square root right here. So b squared minus 4ac, what do we call that? What is the name for this expression right here? And what does it tell us? Any thoughts from the crowd? Called the discriminant. Excellent. Thank you, Kendra. And what does it tell us? You don't have to write me the whole, like, if it equals this, then this, just in general. How many zeros? Absolutely. Remember, if our discriminant is a positive number, that means A, we can square root it, and we'll get both a positive and negative answer. There are 2 zeros. If our discriminant is equal to 0, well, the square root of 0 is 0. So that would just be negative b divided by 2a. That's 1 0. And then finally, pardon me, if it's a negative number, we cannot square root a negative number. That means there are no real roots. Okay. Number 13. The number means nothing to you guys. The annual budget, B in billions, for the National Aeronautics and Space Administration is approximated by the quadratic relation B equals negative 0.1492x squared plus 1.8058x plus 9, where x is the number of years since 1988. We haven't seen a whole lot of questions where time is referenced like that. Usually we see where x is time, but now we're seeing x is the number of years since 1988. So A asks us to use the model to predict NASA's budget in 2018. So our first task is to find x. If x is the number of years since 1988, and we're looking at 2018, so we'd go 2018 minus 1988 gives us 30. And then we'd sub it into the equation. B equals negative 0.1492 times 30 squared plus 1.8058 times 30 plus 9. Calculate that to 1 decimal place, please. Cool. This number is not going to make sense because I changed it last year, but where's my updated equation? You guys getting a negative number? Negative 71.1 billion. Why our textbooks are needing to be updated, because the models are no longer accurate. Well, whether it makes sense or not, we're just going to write it out right now. Okay? The budget in 2018 is negative 71.1 billion. This is not possible. You cannot have a negative budget. We're just going to go with it because the equation is wrong, and I'm worried if I change it, it'll make B not work. And if we find out B doesn't work, well, we're just going to move on. All right, so B, when does the model indicate that the budget was approximately 12 billion? So we need to remember that B is the budget in billions. So if the budget is 12 billion, that means B equals 12. That would give us 12 equals negative 0.1492x squared plus 1.8058x plus 9. I'll highlight that so I fix it after. So what would our next step be? Can we solve when it's equal to 12? We have to make it equal to 0. So I need to move this 12 over to the other side. That gives me negative 0.1492x squared plus 1.8058x. Now, 9 minus 12 leaves me with negative 3. Do we really want to factor with these decimals? Absolutely not. We're going to use the quadratic formula. This one right here. We've got A is equal to negative 0.1492, B is equal to 1.8058, and C is equal to negative 3. Can you please go ahead? I'm going to sub it all in, and you're going to tell me what the two zeros or the two solutions would be. Okay, so I'm going to simplify my discriminant. And I get that it's 1 point. I'm going to go to 2 decimal places here, guys. 2, 1. So x could equal negative 1.8058 plus 1.21 divided by 2a, or x could equal negative 1.8058 minus the square root of our discriminant, so minus 1.21 over 2a. So I get my 2x values as 2.0 or -1. A lot of calculations, eh? So I get x equals 2.0 or x equals 2.1. Yeah. All right. So the question is, when does the model indicate that NASA's budget was approximately 12 billion? Well, X is the number of years since 1988. So I just add 1988 to each of these. And that would give me, therefore, the budget is 12 billion in 1990. That's that answer right there. And 1998. I'm not going to do 0.1. 1998. And that's how we solve our budget question. Let's move on from that one. I'll give you one more minute to copy this down, and we're going to take a look at this cliff diver question below. All right, let's look at number 14. A cliff diver in Acapulco, Mexico dives from about 17 meters above the water. The diver's height above the water, h in meters, after t seconds is modeled by, you got it, a quadratic relation, h equals -4.9 t squared plus 1.5 t plus 17. Once again, why do we see -4.9 a lot? It has to do with the gravitational constant, which is -9.8. There's a reason it's halved, and that comes in physics in grade 11. So how long is the diver in the air? Well, we need to ask ourselves, what is their height when they hit the water? Feel free to send it in the chat. I'll just answer for you. When they hit the water, the height is 0. That's right here. They're starting here, initial height is 17, diving off and hitting the water. We don't know what time they hit the water at, but we know that the height is 0. Now we need to remember, with a quadratic relation, it's symmetrical, so I'm going to kind of scoot that back a little bit. Now we need to solve for what t does h equal 0. What I do is I let the equation, or I set the equation to be equal to 0. And then I have two options. I can either factor this expression and then find t that equals 0. Or if it's numbers that aren't going to factor easily, like, I don't know, 4.9, I can use the quadratic formula. So a is -4.9 B is 1.5, and C is 17. Write out your full solution for quadratic formula, please. I get to this point, I've solved my discriminant. It is positive. That's good. I know there's going to be 2 zeros. And here's where it's going to branch off because of this plus minus piece, right? So t equals negative 1.5 plus 18.32, or t equals negative 1.5 minus 18.32 divided by 2a. So I've got two possible answers here. Which one is correct? And why? 2.02, good. We can rule out negative 1.72. How come? Okay, so here, I see what you're saying. It can't be negative. I need you to be a teeny bit more specific. Why can't we have a negative answer in this specific situation? He's jumping forward, so that would be if our x-axis was distance. Our x-axis is time, though. So can we have a negative time? No. We're going to rule out no negative time. So that means, therefore, he hits the water at 2.02 seconds. The end. Wrap that question up and we'll move on. We are next talking about, vehicle driving. You guys are starting to drive. All right, let's move on. Next question. The algebraic relation D equals 0.0056 s squared plus 0.14 s models the relation between a vehicle's stopping distance d in meters and its speed s in kilometers per hour. What is the fastest that you could drive and still be able to stop within 80 meters? Right here, 80 meters, we see that d equals 80. That means I'm going to sub in here 80 equals 0.0056 s squared plus 0.14 s. Remember that to solve our quadratic relation, it has to be equal to 0. When I move that 80 over, I'm left with 0.0056 s squared. I'm trying to make sure my s's look less like 5s, plus 0.14 s minus 80. And there's my A, B, and C values. Go ahead, solve for what speeds you'd be able to stop within 80 meters. What's the maximum speed? So S equals negative 0.14 plus minus the root of 0.14 squared minus 4 times 0.0056 times negative 80 divided by 2 times 0.0056. Zero point 0.14 squared minus 4 times 0.0056 times negative 80. Root of 1.81. I'll do that again. So I'm going to subtract the root of the discriminant. All right, I got two possible speeds. Which one is my answer? And why? Is the fastest I can. Perfect, Anna. 107.6 kilometers per hour, because we can't have a negative speed. I'm going to squeeze my therefore sentence over here. Therefore, the fastest you could go and still stop within 80 meters is 107.6 kilometers per hour, because S is speed in kilometers per hour. Our next question, we're given the speed. S equals 120. Go ahead and calculate the distance it would require to stop, please. And if you are starting to study for your driver's test, or maybe you completed it already, or maybe it's coming up, where did I get negative 1.81? This is our discriminant here, Victoria. So 0.14 squared minus 4 times 0.0056 times negative 80 gives me 1.8116, and I rounded it to 1.81. And sorry, this is why you have to keep, significant space between you and the car in front of you, because it takes a long time to stop the faster you go. Right, so D equals 0.0056 times 120 squared plus 0.14 times 120. Which gives me 97.44. That means when driving 120 kilometers per hour, it will take 97.44 meters to stop. It's almost 100 meters. That's the length of a football field, guys. Gotta have good reflexes. Wrap that up. How are we doing on time? Okay, we're gonna do two more. This next one's a little bit trickier. All right, a rectangle is 3 centimeters longer than it is wide. The diagonal is 15 centimeters. Find the dimensions of the rectangle. Whoa. Right here, we have an unknown. I'm going to say let X represent width. So that's X, my width right there. What then would the expression be for my length? If it's 3 centimeters longer than it is wide, then my length would be X plus 3. Now, how do we relate these sides together? We don't know the perimeter, so we can't just add them together and solve for X. But there is a way, there is a relationship exists that between, a relationship that exists between this side, and our diagonal. That's also known as the hypotenuse. The Pythagorean theorem, way to go, Opie. So we know that a squared plus b squared equals c squared. Well, here we have a, b, and c. Hooray! All we're going to do now is sub in. So that means that x plus 3 squared plus x squared equals 15 squared. That means that, let's FOIL. So that's x plus 3 times x plus 3 plus x squared equals 225. FOIL to get the full expression here. And once I simplify, that would give me 2x squared plus 6x plus 9 minus 225 equals 0. So 2x squared plus 6x minus 216 equals 0. Now we could use quadratic formula, but let's factor. Let's pull out our greatest common factor, which is 2. 216 divided by 2 is 108 equals 0. We can use simple factoring for this middle one now. So we need to list all the factor pairs for negative 108. And we're looking for one that would add up to positive 3. That could be negative 1 and 108, positive 1 and negative 108. Negative 2 and 54, positive 2 and negative 54. Keep on going, guys. Negative 3 and 36, positive 3 and negative 36. Negative 4 and 27, positive 4 and negative 27. 5, no, 6. Yep. Negative 6 and 18, positive 6 and negative 18. Not 7. Not 8. We could have negative 9 and positive 12, or 9 and negative 12. Oh, pretty sure this right here adds up to positive 3. That means x minus 9 times x plus 12 times 2 equals 0. Right, so that means that x minus 9 equals 0 and x plus 12 equals 0. Find x. We get x equals 9 or x equals negative 12. We can't have a negative length, so it's not negative 12. Now we said that x represents width. So that means the width is 9 centimeters. And the length is x plus 3, so it's 12 centimeters. And we're done that one. We're going to do one more. Okay, I'm going to go on. Remember, if you need this later, you can come back to the video. Okay, last one. A bus company has 4,000 passengers daily, each paying a fare of $2. For each 15-cent increase, the company estimates that it's going to lose 40 passengers. If the company needs to take in, needs the revenue every day to be $10,450 to stay in business, that's covering the cost, what fare should be charged? So I gave you the equation on this. R is revenue and X is the number of fare increases. So my riders is 4,000 is my original value. Then we lose 40 for every price increase. My fare is $2 as the original value, adding 15 cents for every increase. Now we need our revenue to be this value. So I'll sub that in for R. Like so. First things first, I'd like you to use FOIL to expand that. And I'm going to wait. so here's what you should get. Remember, we need to have the equation set to 0 to solve. So that's negative 6x squared plus 520x. Now, 8,000 minus 10,450 gives us negative 2,450. And these are going to be some big numbers to factor, so let's use quadratic formula. We got A equals negative 6, B equals 520, and C equals negative 2,450. Solve for x, please. $520 squared minus 4 times negative 6 times negative 2,450. Whoa. My discriminant value is 211,600. Let's figure out our two x values. All right, so I have some x values, but I'm not done. Because what does x represent? X represents the number of fare increases. And the question has asked us, what fare should be charged? We're actually not going to do this next question, so I'm just going to scribble it out so I have space to write. So our fare is $2 plus 0.15 cents for every fare increase. So that means that if we're increasing 5 times, that would be $2.75. Or if we're increasing 81.7 times, I feel like that's going to be a pretty expensive bus ride. 2 plus 0.15 times 81.7. Yeah, $14.26. But these are two valid options. So the company should charge $2.75 or $14.26. I have a feeling they lean towards $2.75, but that's an option as well. So that finishes off, our word problems for today. Actually, for our whole unit. You have a quiz to complete for this week. Your word problems are actually due next Thursday, and I'm going to open the test next Wednesday or Thursday. I just need to coordinate with Miss Nicola and Miss Rowden. So next week will just be review and the test. And then the week after that, we move on to our trigonometry, our final unit. So stick around, guys. If you have questions or want to go through another problem, if you're feeling like you could probably go try some of the homework on your own, away you go. Have a great day.